In this video, I'm going to solve every question from the 2024 Intermediate Maths Challenge, which is one of the UK's main maths challenges aimed at students aged 13 to 16. There are 25 questions in total, all multiple choice, and in 2024, you would have needed about 9 or 10 correct to get a bronze certificate, 12 or 13 to get a silver, about 16 to get a gold, and around 19 to 21 out of 25 to qualify for the Olympiad round. If you're interested in exactly how the scoring works and grade boundaries for other years, take a look at the Mathsaurus website, which has a lot more information as well as a totally free course where you can practice all of these questions and lots more. So let's start the 2024 paper now. I'll put timestamps below so you can jump to the questions you need, or you can work through the whole paper with me and pause the video at the start of each solution. And don't forget to let me know how you get on in the comments. They always like to get the year into Maths Challenge questions, and this was the first question from the Intermediate Maths Challenge from 2024. Work out 20 plus 24 divided by 20 minus 24, and if we just work out the numbers, we get 44 divided by minus 4 equals minus 11. So quite an easy one to start with. You could perhaps save yourself a fraction of a second by dividing top and bottom by 4 first and getting 5 plus 6 divided by 5 minus 6, and then 11 divided by minus 1 is minus 11, but it's not really worth worrying about too much. Just get the answer and move on. What is the difference between the smallest two-digit prime and the largest two-digit prime? Let's think about the largest two-digit prime first. Well, 99 isn't prime, that's 9 times 11. 98 is an even number, 2 times 49. So 97 is our first candidate for being prime. Now for two-digit numbers, you've just got to check whether they're divisible by 2, 3, 5 and 7, and if they're not divisible by any of those, then they will be prime, because to test for prime numbers, you just need to check all the prime factors up to the square root of the number. Here, the square root would be smaller than 10, so we only need to check 2, 3, 5 and 7. When you do that, you see 97 isn't divisible by any of those, and so it really is prime. For the smallest one, 10 is 2 times 5 and 11 is prime, so the largest is 97, the smallest is 11, and the difference is 97 minus 11, which is 86. If t is the midpoint of the side QP of this square, what fraction of the square is shaded? Well, let's call the side length of the square 2x, and then half of the side length, x, would be the distance from p to t. The square would have area 2x all squared, which is 4x squared. The triangle would have area 1/2 base times height, and the perpendicular height here would be 2x for that triangle if we take the base to be x, the side pt. So its area is 1/2 times x times 2x, 1/2 times base times height, which would give us x squared. X squared divided by 4x squared is 1/4, so it takes up 1/4 of the area of the square. There are other ways to do this question. You could also notice that this top triangle is 1/2 of the whole square, and so this bottom one is 1/2 of 1/2, which is 1/4, which leaves 1/4 for that remaining triangle. You could even say something like, you know that that formula 1/2 base times height would work on this shaded triangle, and it would have the same base and height as this triangle, and so that one has area 1/4 of the square, and so the shaded one must have area 1/4 as well. Lots of ways to get to the same answer here. The shortest sides of a right angle triangle have lengths root 5 and root 12. What is the length of the hypotenuse? Well, don't fall into the trap here. You might have recognised your Pythagorean triples and go straight for 5, 12, 13. Of course, if it was 5 and 12, then the hypotenuse would be 13. But actually here, if we apply Pythagoras, we get the square root of 5 squared plus the square root of 12 squared. That would be equal to x squared. So x squared is 5 plus 12, which is 17, and x is the square root of 17. That's the length of the hypotenuse. This question can teach you a lot about averages. The ages of Granny's 7 grandchildren are consecutive positive integers. The youngest 3 grandchildren have a mean age of 6. So what's the mean age of the oldest 3 grandchildren? And the fact that they're consecutive positive integers is really going to make a difference here. And in particular, when values are evenly spaced out, like consecutive integers are, then the median, the middle value, is going to be the same as the mean when we've got an odd number in that list. So the median is 1 in the list, of course. Let's write it down algebraically to make it clear. So the 3 youngest we could write as x minus 1, x, and x plus 1. So if I add those together and divide by 3, I would get the average of 6. Another way of saying that is that the total of their ages is 6 times 3 is 18. And when I add x minus 1, x, and x plus 1, we get 3x. So I've got 3x is 18, and x equals 6. So those youngest children are ages 5, 6, and 7, which means the other 4 children are 8, 9, 10, and 11.
Here we want the mean age of the oldest 3 grandchildren, that's the ones aged 9, 10 and 11, so that's 9 plus 10 plus 11 over 3, which is 30 over 3, or 10, or you could just say that 10 is the median of those 3 numbers, and because they are symmetrically spaced, it's also the mean. Either way, the answer is C, 10.
4 of these points lie on a circle. Which of them does not lie on that circle? Well, there's different ways you can go about this question, depending how much mathematical experience you've got. For a maths challenge, just plotting the points here, it will get you quite a long way. So if we plot 0, 5, 5, 0, 3, 4 and 4, 3, you see they all lie on something that looks like a circle here, and C, 2, 2 appears to be somewhere else. So for the purpose of a maths challenge, that would be fine. You might also know that a circle centred at the origin is of the form x squared plus y squared equals r squared. For this one, the radius would be 5, so we've got x squared plus y squared equals 5 squared. And you can spot those Pythagorean triples, 3 squared plus 4 squared equals 5 squared, in there as well, to show that the points 3, 4 and 4, 3 lie on that circle. So with some experience here, you probably would just spot straight away that A, B, D and E all satisfy that, and that it must be a circle centred at the origin. But there's not anything in the question that immediately tells us that it's centred at the origin, but that is where it would be. So 2 ways to do that question anyway, and either way the answer here is C, 2, 2 is not on the circle. Approximately how many grains of rice are there in a can of rice pudding? In particular from this made-up brand Penny's Puddings from the Intermediate Maths Challenge. They usually do fact check their answer, so I imagine this is a sensible amount of rice in a can of rice pudding. But let's do the maths question anyway. So it says there's 25,000 cans that between them have 50 million grains of rice approximately. So how many in each can? Well, 50 million is written like this. We divide it by 25,000. We can cancel 1,000 top and bottom, that's 3 zeros, leaving us with 50,000 over 25. And 50 divided by 25 is 2, so that gives us 2,000, and the answer is B, approximately 2,000 grains of rice apparently in a tin of rice pudding. Let me know if you think that is realistic or not. Algebra can be a great way to explain these sorts of questions, I think. So we need to work out 999 times 999 plus 999, and the idea is not to do a really long-winded calculation here, but just to recognise that this has the same structure as 999x plus x, where x is 999. So if I add those together, I'd get 1000x, right? I've got 999 lots of 999 and another 1 lot of 999, so that gives me 1000 lots of 999, and that's 999,000. So the answer here is C. What's the perimeter of this strange looking shape if the sections that have been removed here all have a perimeter 18 millimeters? Well, the sectors that have been removed from this hexagon, I could label them with their straight sides as X and the curved part as Y. So a sector would be 2 lots of X plus Y for its perimeter, and that would be equal to 18. When I look at the whole of this strange shape and I go all the way around, I see I've got X's for all the straight edges and Y's for all of the curved ones, and so we have 6 straight and 3 curved. That's 6x plus 3y. Factorising, that's the same as 3 times 2x plus y. 2x plus y we said was 18, so the perimeter must be 3 times 18, which is 54 millimeters, and the answer here is D. You don't need to do much actual multiplication here in this fractions question to get the answer. Let's work out 20/24ths plus 20/25ths without doing any multiplication. We know to combine these into a single fraction, we want to go for a common denominator. 24 and 25 don't have any fractions in common, so we do have to make that 25 times 24. So we would get 25 times 20 plus 24 times 20 divided by 25 times 24. But on the top, we can just say we've got 25 lots of 20 and 24 lots of 20. That's 49 lots of 20, which is 25 plus 24. Again, think of it like 25x plus 24x, where x is 20 if you want to. And on the bottom, let's write 25 as 5 times 5, and 24 is 4 times 6. Well, now we've got a 5 times 4 on the bottom, which can cancel with a 20 on the top, and then I do have to do one bit of multiplication at the end of the question, but it's an easy one. 49 over 5 times 6, and 5 times 6 is 30, so we get the answer of B, 49/30ths. What percentage of the area of this square is covered by the frame? So the overall size is 80 by 80, and we've got this frame width of 4 centimeters. So the inner square would be 80 minus 2 lots of 4, which is 80 minus 8, or 72 centimetres. I'm going to do this with the difference of two squares, because the outer frame is the larger square on the outside minus the smaller square on the inside. So that would be 80 squared minus 72 squared would be the area of the frame. So the percentage I want to, or for the fraction I should say, I want to divide that by the overall area 80 squared. To get the percentage, I'll just multiply it by 100 at the end. But the difference of two squares formula can help us now, because 80 squared minus 72 squared is 80 plus 72 times 80 minus 72. Remember the difference of two squares that says that x squared plus y squared is x plus y times x minus y. And now, again, I'm going to try to avoid doing too much actual computation here. 80 plus 72 is 152, 80 minus 72 is 8. If I cancel an 8 with one of the 80s, then we're just left with 152 over 800. So all I've got left to do is to do 152 divided by 8, which you can do as a long division, or you can say 20 lots of 8 is 160, so 19 lots of 8 is 152, and we're left with 19 over 100. So as a percentage, times it by 100 and you get 19%. I don't think this question is really as hard as it looks, but you can learn something really nice from it. I've got to work out the length of x here in this diagram. Now by Pythagoras theorem, if I start with a triangle that has the shorter sides as 1 and the square root of some number, let's call it a, then the hypotenuse, well, I square 1 to get 1, I square root a to get a, then the hypotenuse has length the square root of 1 plus a. So all it is, if I've got 1 and root a, then the hypotenuse is just root 1 plus a. It's 1 larger than the number I started with. So when I look at this diagram, I've got the first one, 1 and 1, so the hypotenuse is root 2. And now I've got this situation where a is 1 and root 2, so the new hypotenuse will be root 3. Well, I've got the same again now with 1 and root 3, so I get root 4. And then all of these hypotenuses keep going up by 1, root 5, root 6, root 7, root 8, and finally x is the square root of 9, and of course that is 3. There's an art in maths challenge questions of when to use trial and error on the answers and when to do something more complicated like algebra. It's one that you really only master by doing lots of practice to really get the experience of having a good idea as to which approach is going to be better. You could just go through and trial and error these and it wouldn't take you too long. It wouldn't be a bad approach. But I do think if you're just slick with algebra, you can dispatch this with algebra actually very quickly. I increase the number by 20%. That, let's call the number x, so I've got 1.2x. I get twice as much as when I decrease 20 less than the number by 20%. So 20 less than the number is x minus 20, decrease that by 20%, I multiply it by 0.8, and finally I'm saying it's twice as much as, so I've got a 2 outside of the brackets here as well. Pause and really take that in if you need to. But now I've just got to multiply out the brackets and solve the equation, so I much prefer this way. 1.2x is equal to, well, 2 times 0.8 times x is 1.6x, and then I need 1.6 of 20, 6 times 2 is 3.2, so that's 32. So I've got 32 is equal to 1.6x minus 1.2x, which is 0.4x, times it by 10, 320 is 4x, divide by 4 and get x equals 80, and we're done. In your head, you can do that a lot faster probably than I say it out loud. If you prefer to do it by checking each answer, you can do, but I really think algebra is the best way to go for this question. Which of these statements about quadrilaterals would be true of one whose angles are in the ratios 6 to 7 to 8 to 9 going clockwise around the quadrilateral? Well, 6 plus 7 plus 8 plus 9 is 30, and 360 divided by 30 is 12. So each part of this ratio is equal to 12 degrees, and I can multiply the 6, 7, 8 and 9 by 12 to get the number of degrees of each of the angles. 72 degrees, 84 degrees, 96 degrees and 108 degrees. We can see immediately that it is not going to be right angles because there are no 90-degree angles there. We can also rule out it being a cyclic quadrilateral, because in a cyclic quadrilateral, opposite angles have to sum to 180 degrees. Now there are pairs that sum to 180 degrees here, but we're told that they are going clockwise around the shape. So it would have to be the 72 and the 96 and the 84 and the 108, which add to 180 to make this work. They don't, so it is not cyclic. Is it a kite? Well, a kite, if you think about it, has to have two equal angles. There's no pair of equal angles in this shape, and so it can't be a kite. And similarly for a parallelogram has two pairs of equal angles, and so it's certainly not a parallelogram because we don't have any equal angles. We're left with it being a trapezium then as the only option, and you can check it really does work here. If you draw a trapezium like this and label the angles, then we have the two parallel lines in the trapezium top and bottom here, and that means that those co-interior angles have to sum to 180, so we've got 72 and 108 adding to 180, and 84 and 96 adding to 180. They're the angles next to each other, and so they are exactly what we need for it to be a trapezium.
We're going to do this question in two ways because there's a really important general method that you can learn from it. So Carry the cat and Barry the bat together weigh 4,000 grams more than Rolly the rat. Let's write that down in algebra. That would be C plus B equals R plus 4,000, where of course C, B and R are the weights of the individuals, Carry, Barry and Rolly. And Barry and Rolly together weigh 2,000 grams less than Carry, so we can write that as B plus R equals C minus 2,000. And Carry and Rolly together weigh 3,000 grams more than Barry, so that's C plus R equals B plus 3,000. So when you've got a situation like this where you've got several equations but there's symmetry, a method that very often works here is to just add everything together, to combine all of the equations together. We'll do it in another way in a second as well, but if I just add A, B and C here together, that's the names I'm giving to these three equations. On the left hand side we can see we'd have two lots of B, two lots of C and two lots of R, and on the right hand side we've got one B, one C and one R, and then 4,000 plus 3,000 minus 2,000 gives us 5,000. So if I subtract a B, C and R from each side, we're left with B plus C plus R equals 5,000. And this often happens in symmetry questions. In fact, they often ask you what's the total of their weights, and then we'd be finished here. The total would be 5,000. Here we need to do a bit more though, so if we look also at equation A, we've got that C plus B equals R plus 4,000. I could substitute in for the B plus C here and get R plus 4,000 plus another R, so that's 2R plus 4,000 equals 5,000. Then subtract 4,000 from each side to get 2R equals 1,000, and finally divide by 2 to get R equals 500, so that will be 500 grams for the weight of Rolly, and the answer is B. You might notice there is actually a faster way to do this, even though I like this more general approach because you can use it for a lot of different problems. If you had just added together equations B and C, you would get directly B plus C plus 2R equals B plus C plus 1,000. I could subtract B plus C from each side and get 2R equals 1,000 and R equals 500 that way as well, but either way gets us to the same result. This is a sneaky little question from the Intermediate Maths Challenge. Factorial n, or n factorial, is defined by n factorial is 1 times 2 times 3 all the way up to n. And we want to know what the remainder is when 1 factorial plus 2 factorial plus all the way up to 10 factorial is divided by 5. Let's start writing out some of these factorials. 1 factorial is 1, 2 factorial is 1 times 2, which is 2, 3 factorial is 1 times 2 times 3 equals 6, 4 factorial is 1 times 2 times 3 times 4, which is 24. Now don't worry, we're not going to have to write them all out, otherwise this would be a very laborious question. When we look at 5 factorial, 1 times 2 times 3 times 4 times 5, well we see it's 120, but most importantly we see that it's a multiple of 5. So if I divide it by 5, the remainder would be 0. And that's actually true for the rest of the factorials in this list, because 6 factorial would have a 5 times 6 at the end, so it would, in particular it will be a multiple of 5. 7 factorial also has that 5 in it, so it's a multiple of 5. 8 factorial, 9 factorial and 10 factorial would also be multiples of 5. So we can ignore those. When we add them together and divide by 5, it will still be a multiple of 5 divided by 5 and leave remainder 0. So we just think about 1 factorial, 2 factorial, 3 factorial and 4 factorial. What do they leave as a remainder when divided by 5? Well, 1 factorial gives us 1, 2 factorial gives us 2, 3 factorial is 6, so 6 divided by 5 leaves remainder 1, and 4 factorial is 24, that leaves remainder 4. You could have added them up and then worked out the remainder, but I've worked out the remainder, so we add them together. 1 plus 2 plus 1 plus 4 is 8, and that's 5 plus 3, so the total will give us a remainder of 3 when divided by 5. What is 4 to the 3 squared divided by 4 to the 3 squared? If you were not watching this and just listening to the audio, you might be tempted to say 1, but we've got brackets in different places here. So the first 4 to the 3 squared has the 3 squared in brackets there, so that means 4 to the 9, and the second one is 4 to the 3 in brackets, then squared. So by the rules of indices, that's 4 to the 3 times 2, which is 4 to the 6. So I've got 4 to the 9 divided by 4 to the 6. Again, by the rules of indices, it's 4 to the 9 minus 6, which is 4 cubed, and 4 cubed is 64. This is quite a tricky question from the Intermediate Maths Challenge from 2024. We've got the point P with coordinates -1, 4. That's reflected in the y-axis to become Q. The point Q is reflected in the line x equals y to become R. And then the point R is reflected in the x-axis to become S. So let's draw a diagram. That's crucial for this sort of question. We've got the point P with coordinates -1, 4. That would be over here. I'm going to reflect that in the y-axis. So the y-coordinate is going to stay the same. And the x-coordinate is going to change from -1 to 1. To give us the point Q with coordinates 1, 4. Now I'm going to reflect in the line x equals y or y equals x, and when you reflect in the line y equals x, that swaps the role of x and y. So it's going to swap the x and the y coordinates, and so the point R will have coordinates 4, 1, and then I'm going to reflect in the x-axis, so the x coordinate will stay the same this time, and the y coordinate will change from 1 to -1 to give us the point S at the bottom with coordinates 4, -1. Now, you could here work out the area of this quadrilateral, which is a trapezium, using the formula for a trapezium, half a plus b times h. All of those things are possible to work out here. But if you want a nice fast maths challenge method for this, we could add in another point here, 4, 4, and see that the trapezium that we've got here is a large triangle minus a smaller triangle. The smaller triangle has side lengths 3 and 3, and the larger one 5 and 5, so I just need to do half base times height for each of those, a half times 5 times 5 minus a half times 3 times 3, that's a half of 25 minus 9, or a half of 16, which gives us 8, and so the answer here is E. This is an unusual type of magic square. Usually in magic squares we've got the rows, the columns, and the diagonals adding to the same total. Here we've got them multiplying to the same total. It says that each column, each diagonal, and each row give the same product. So what's the value of x? Well, if we start by looking at the bottom row, we can see that the magic product here is 2 times 3 times x, which is 6x. On the vertical column here, I've got x times 6 times something is 6x, so it must be then that top middle entry is just 1. On the diagonal here, I've got 2 times 6 times something, let's call it y. That would also be equal to 6x, so I've got 12y equals 6x, or y equals x over 2, so I've got an x over 2 here, and we could now look at the top row here and say, okay, we've got x over 2 times 1 times something, let's call it z, that's also equal to 6x, so that gives me zx over 2 equals 6x. Now, assuming x is not 0, which it's not, because we're told they're all non-zero numbers, otherwise we could have a solution where all the products are 0 here, I can divide by x, and then that would give me that z equals 12 here. So now we could look at this diagonal, and we can say we've got 12 times 6 times 3, that's also equal to 6x, so dividing by 6 each side, that gives me x equals 12 times 3, which is 36. There would be other routes to get to x as well, that's just one of a number of possible ways there, but all of them should lead you to A, 36 as the answer. So how good is this offer? A shop sign says, t-shirts, 3 for the price of 2, equivalent to a saving of £5.50 on each t-shirt. Must have been written by a mathematician, this sign, not being very transparent about what's going on, trying to make you solve a puzzle before you get your discount. So using this special offer, what is the cost of 3 t-shirts? Well, if it's 3 for the price of 2, that means the saving is 1/3 of the total. So it must be then that the saving is £5.50 times 3, which is £16.50. So one of the t-shirts is equal to £16.50. 3 of them would be 3 times that, which would give you £49.50. But of course, we're only paying for 2 of them under the offer, so we want 2 times £16.50, and that's £33. And so the answer here is D, £33. We've got quite a classic challenge-style geometry problem here, where we've got a square of side length 4 centimetres with 4 identical semicircles drawn with their centres at the midpoints of the sides, right in the middle of those sides. The 4 semicircles touch 2 other semicircles as shown, so they intersect just at a point there, and we want to know what the shaded area is. The key to a lot of these geometry problems is adding in some additional lines that help us solve the problem, and interesting points in these sorts of questions will be where the circles touch, the centres of the circle, things like that. And it turns out here, if I draw another square that goes through the centers of the circles and all of those points where the circles touch, we have a really nice way of solving this problem. So we draw that on, and we notice that we know the side length of that square because half of the side length of the big square is 2 centimeters, that's half of 4 centimeters. So I've got a right angled isosceles triangle in each corner, and by Pythagoras, this hypotenuse that we could call x briefly, x squared is 2 squared plus 2 squared, so I've got x squared equals 8, and x is the square root of 8. And we could also, if we want to, write the square root of 8 as 2 root 2. That means that the radius of the circle is exactly a half of 2 root 2, which is just 1 root 2, because again, we've made the side length of that square pass exactly through the point where the circles touch, and so it's exactly the length of 2 radii of those identical semicircles. So to work this out, we've got a square that's got side length root 8, and we've got these 4 parts of the semicircle that actually, because they've got right angles of the square here, we can see they're exactly quarter circles. So I could put those 4 quarter circles together to give one whole circle. Then the shaded area would be the area of the square, that would be root 8 squared, which is 8, and the area of the circle made up of those 4 parts would be pi r squared, where the radius is root 2, so pi times root 2 squared, that's 2 pi. That means the shaded area is the difference between those values, 8 minus 2 pi, and the answer here is E. See if you can visualize this one. When a cube is cut into 2 pieces with a single plane cut, 2 polyhedra are obtained. Which of these polyhedra cannot be obtained in this way? Well, the easiest way to do this one, I think, is to find all of the ones that can be obtained. So the one that jumped out at me first was a 4-faced polyhedron. That just means a 3D shape with flat sides, and if you cut through like this with a triangle, you'll get a pyramid on one side with a triangular base, and so that would have 4 faces. Now, if you think about what you're left with once you've cut off that pyramid, you can also see that the rest of the cube will still have 6 faces with a bit chopped off, and it will now have this extra triangular face on it. So that one would be a polyhedron with 7 faces. To get 6 faces, I think, is quite easy because you could just slice the cube in half and you're left with a cuboid which also has 6 faces. So we've just got 5 or 8 to choose from, and then we notice we can just push the edge of the cuboid that we've just had on the top there to be in line with the edge of the cube, and that will leave us with this wedge shape that would have just 5 faces because we've just removed that top face from the cuboid essentially. So we found 4, 5, 6 and 7. We haven't found one with 8. It would be a bit harder to justify absolutely why that's not possible, but a maths challenge question here, we know that E must be the answer at this point, and so we can happily move on. This is a very tough little geometry problem from the Intermediate Maths challenge. We've got a circle inscribed in a semicircle with centre O and diameter AB. The centre of the circle is at the point P, and PA equals PO. We want to know the ratio of the radius of the circle to the radius of the semicircle. Let's call the radius of the semicircle, the larger circle if it were a full circle, capital R, and the radius of the smaller circle, small r. And we'll try to write some things down in terms of those values. In particular, I'm going to draw a triangle here with a line from P to O and a perpendicular line from AO to P. Now the length PO is going to be capital R minus small r, the radius of the larger circle, minus the radius of the smaller circle, as you can see here. If you're worried about that at all, notice that there's a common tangent at the point where the circle intersects the semicircle at the top there, and so both of the radii from that point to P and from that point to O will be perpendicular to that tangent, and so we really do get a straight line here, and we can write that PO is capital R minus small r. Clearly we've got this vertical line is the radius of the smaller circle, which is small r, and then the base of the triangle here is going to be capital R divided by 2, because AO is a tangent to the small circle, so we've got a right angle triangle here, and we know that PA is equal to PO, so I could draw another triangle like I have just to the left of it with PA also equal to capital R minus R, and we can see they would be 2 congruent triangles, so this point really must be halfway along AO. But this is a right angle triangle, and we can apply Pythagoras theorem to it. So we've got small r squared plus capital R over 2 squared equals capital R minus small r all squared. Multiplying out, we've got small r squared plus capital R squared over 4 equals capital R squared plus small r squared minus 2 times capital R times small r. We've got fractions here, so if we multiply through by 4, we would get this line, and we can see we've got a 4 small r squared on each side that we can subtract, and doing a little rearrangement gives us 8 times capital R times small r equals 3 times capital R squared. We know that the radius of each of these circles isn't going to be 0, that wouldn't make sense in this problem, so I can divide through by capital R and get 8 times the small radius equals 3 times the large radius, so that finally gives us a ratio of 3 to 8, and the answer here is B. I bet not many people got this question right. It's a tricky one, but you can make it a lot easier if you use one of these standard results about hexagons that are so useful in the maths challenges. What we're trying to do here is essentially work out the distance from P to Q one way around this hexagon and the distance from P to Q the other way around the hexagon. If you read the question, they talk about people walking around the lengths of their hexagon here, but it essentially comes down to that. So if I draw a few lines inside the hexagon here, we can see that we can always split a hexagon, a regular hexagon that is, into 6 equilateral triangles. So if I look at these two halves of those triangles on the right, they would combine to give one of those equilateral triangles, and so I've got this red shaded area here of 1/6 of the overall hexagon. But we're told that the shaded pentagon, the whole shaded area that is 1/4 of the whole shape. So this strip down the middle here is going to be exactly 1/4 minus 1/6 of the whole of the hexagon. 1/4 minus 1/6 is 3/12 minus 2/12, which is 1/12. So the strip is 1/12 of the hexagon. So if we consider the rectangle UTRW here, the centre part of the hexagon, that would be made up of 4 of those equilateral triangles in total, or two of them and 4 halves if you like. So overall, that's 2/3 of the hexagon, and that's 8/12 of the hexagon. So the rectangular strip PTRQ is 1/12 of the overall hexagon, and this larger rectangle UTRW is 8/12 of it. So it must be that PT is 1/8 of the distance UT, or QR is 1/8 of the distance WR. No, this rectangle is 1/8 of the larger rectangle that it's inside. So we can count the distance from P to Q, which in the context of the question is how far J walks, as 2 and 2/8 sides, 2 full sides and 2 of those 1/8 sides. That's 2 1/4 or 9/4 sides in total. The distance from P to Q the other way, the distance K walks, would be 2 full sides and then 2 lots of 7/8, so 14/8 sides. That gives us in total 3 3/4 sides or 15/4 sides. So that means that the ratio of the distances walked is 9/4 to 15/4, or 9 to 15, which we can simplify down to 3 to 5 and get that the answer here is C. This question is so much harder than it looks, not surprising because it was question 25 of the Intermediate Maths Challenge, so it's always going to be something we expect to be difficult. So let's have a go at it. We've got a gold coin worth X% more than the silver coin, and the silver coin is worth Y% less than the gold coin. And we're told that both X and Y are positive integers, and we want to know how many possible values for X are there. You might start this question just by seeing if you can find some values that work, like if one value is 25% more than another, then that means the other value is 20% less than it. For example, 100 increased by 25% gets you to 125. I take 20% of 125, that's 25, and it brings me back to 100. So there are some values that work here, and we can see that the answer is definitely not going to be 0, so we need to explore further. Let's think about the scale factors involved. If we write the percentage increase as a scale factor from the silver coin to the gold coin, a percentage increase of x would be 1 plus x divided by 100, which I can write as 100 plus x divided by 100. If I wanted to reverse that scale factor and get the scale factor that goes from the gold coin to the silver coin, I would do the reciprocal of the scale factor. I would do 1 over the scale factor, which for a fraction means turning it upside down to give 100 divided by 100 plus x. The reason I've done that is because I want to express it as equal to the scale factor in terms of y, where we say the silver coin is worth y% less than the gold coin. Because then the scale factor would be 100 minus y over 100 for a decrease of y%. So those two scale factors must be equal, and that's the key to this question. The increase of x% is equal to the decrease by y%, so I can write an equation that those scale factors equal 100 divided by 100 plus x equals 100 minus y divided by 100. Multiplying through by 100 gives 100 squared equals 100 plus x times 100 minus y, and we now see that this becomes a number theory problem, because I need to think about the factors of 100 squared, or 10,000. Now, 100 squared is 10,000 is 10 to the power of 4, which is also 2 to the 4 times 5 to the 4. That's its prime factorization, and I'm going to use that when I list out the factors. But the key here really is that 100 plus x and 100 minus y have to both be factors of 10,000, then I can multiply them together and they give a solution here. So let's think about the possible values of 100 minus y and 100 plus x, and I'm going to use that prime factorization to order them nicely. So I'm first going to think about all the factors that don't have any 2's in them, and then the ones that do have a power of 2, and then that have 2 powers of 2, and so on. So the factors that don't have any powers of 2 in them, i.e. the odd factors, would be 1, and that would pair with 10,000. That would give us a possible solution here. 100 minus y could be 1, and then y would be 99, and 100 plus x could be 10,000, and so x would be 9,900 here. I'm not going to explicitly write down the values of x and y here, we'll just know that we can find them. So we could also have 5 and 2,000, we could have 25 and 400, but if I go further than that and go to 125, this is now no longer a possibility, because 100 minus y would have to be 125, and so y would be negative. So actually I need in this column on the left only values that are going to be less than 100, otherwise y will not be a positive integer. Let's look at the factors that have a single power of 2 in them now. So we could have 2 with 5,000, we could have 10 with 1,000, 50 with 2,000, and then the next one will be 250. Again, that's too big. It would mean that y would have to be negative. If I look at the factors that have 2 squared in them, so 4 and 2,500, then multiplying by 5, 20 and 500, that works. But the next one would be 100 and 100, and again, that doesn't work because that would make x and y have to be 0, but they need to be strictly positive. So if we go for factors that have 2 to the power of 3 in them, so we've got 8 with 1,250, 40 with 250, and then again the next one will be too big, would have 200, which would be too big. For the final ones, we'll use all of the 2's, the 2 to the power of 4, which is 16, so that would give me 16 that compare with 625, and 80 which compare with 125, and again the next one, 400, would be too big. So we found 12 factors here. It's also the largest option for the multiple choice answer, so we can be very confident that we're correct and that the answer is E. Notice what we've ended up with here. On the left is a column of all of the factors of 10,000 that are less than 100, and on the right all of the factors of 10,000 that are bigger than 100, and the only thing not in the list is 100 itself. If we were really sharp, we might have just spotted there were going to be this many factors without having to work them out individually. Because 10,000 is 2 to the 4 times 5 to the 4, so all of the factors can be formed by having between 0 and 4 2's in the factorization, and between 0 and 4 5's in the factorization. That gives us 5 times 5, or 25 factors in total. Half of those are going to be smaller than the square root 100, half of them are going to be bigger than the square root 100. That is after we've excluded the 100 itself, of course. So that leaves us with 24 factors, half of which below the square root, half of which above the square root, and we could see that the answer there would be 12 that way as well, but I think most people would probably do some sort of listing in this question. Well done if you've got it right, however you've managed it. Well done on making it to the end. If you'd like to work through even more intermediate maths challenge questions with me, then take a look at this video, which is very much like the one you've just watched, but with all of the questions from 2023.